recall, the problem was about a continuous push down VAS in one dimension. So I will recall the problem here. In the transition, you can either do a +1 or a -1 or a +0, and these are continuous, so this can be scaled by a factor between 0 and 1. And you also have a stack where you can push or pop letters. Moreover, you also have lower bounds on the states. So this state can say that I will accept this transition only if, let's say, it is at least 4. If the vector value is at least 4, then this will accept. So
Shrisha, maybe you can use another marker because it's not really visible on the camera. At least, yeah, some crucial parts. Oh, yeah. Okay. I think this is better, right?
So we had the result that reachability and coverability are in NP, but we didn't know the hardness. But thanks to Georg is not here. He gave a reduction from. So there's a reduction from subset sum to so if there is a CTL language L which is a subset of A star B star, then does there exist a word A M CFL, yes. Sorry. AM BN such that and you are also given two numbers K and L, natural numbers, such that M is at least K and N is M plus N is at least L. So this is also NP hard.
Numbers in binary. Numbers in N
yes,
binary.
yes, in binary. And then this reduces to our problem of reachability and coverability. So now we know that this is NP complete. I think this will also work if we instead only have lower bounds on the states, upper bounds on the states. So this will accept only if it is less than or equal to 4. I have a reduction that it's in NP. I think the reduction should also work. The NP hardness reduction should also work. But the interesting case is when a state has both a lower bound and an upper bound. So the state will accept only if it's in an interval A, B. So this continuous push down bias can be reduced to a reset free time automata. And so reachability and coverability, reachability will at least be NP hard, but we don't have a proof of NP inclusion in this case. So thank you, Georg, for finishing our result.
Okay, that's it, thanks. Any questions, remarks to that?
Yes. Yes, I have a question. So, so the number of counters is unbounded, or it's it's fixed, or?
It's just one counter, one dimension. So the VAS is just one dimensional.
Just one dimensional, but
yes.
If you have several counters, since it is the continuous semantics, can we say something, or it's?
Yes, it was solved by Bala Subramaniam, Georg, Rupak, and It's NEXP time complete.
Okay, so there is a gap of complexity
Yes.
between dimension 1 and higher. And in dimension 2, we also have this complexity. Let's see. Because I know that for vector addition system, dimension 1 and 2 are really different from other.
Yes. We have not yet looked into dimension 2.
Okay. Okay.
I think the proof works from dimension 4 or 5.
Any other remarks, questions? Okay, so thank you.
Thanks.
Our progress report. Well.
There's no blank.
Yeah, exactly.
I erase this one, I turn around and don't erase it.
Okay, maybe you can erase from the end.
This side.
Maybe this side, yeah, maybe we should erase. That or yeah, I think it's okay, yeah, to erase. Do we have another punch? Ah,
Right. A couple of days ago, I mentioned that I thought it was interesting to look at parameterized complexity for probability. So your parameter is the dimension E. Your input is the mass plus source and target configurations. And the question is, can you cover? So here's the update. So there's a class called XNL, which stands for non-deterministic f of the parameter times n to the of 1 log of n space. And so using the bounds of Raka for the new bounds, you get an upper bound in there, and so the new thing is that this works also a lower bound from intersection emptiness of automata. And so this is complete in unary case. So this is the novelty, thanks to how we pointed us to look at these kind of classes. And the upper bound was already known, the lower bound was not so difficult once you knew where to look at. Question remains for binary encoding. What kind of complexity would you get there? This no longer fits, the upper bound no longer fits in there because now the numbers are much larger. And yeah, so maybe XP space might be the right one or not. That's it, I think. Any questions?
So, yes, does it solve really the problem? I mean, in unary, it's
In unary,
completely...
yeah, it solves
Okay.
it. But
This
it
is the
only gives
complex...
you conditional harmless results in the sense that they cannot exist some kind of nice algorithm
I see.
in fixed parameter.
Under what? Not ETH, but something more exotic.
haven't looked at all the implications of this. It's long list.
In the XML complexity definition, the f function can be any function.
Any computable function.
Any
of the
computable
parameter.
function. Because in our case, it's not any computable, it's small function.
It's 2 to the
2 to the p or something like that. But okay, in the complexity class, in that complexity class, just
There are some refinements of these things where you might want to ask that f is not to be.
okay. Yes.
So do you have like conditional lower bounds on the f?
On the f.
Because I mean, there's like in this FPT world we can like know this much better. There's like the exponential time hypothesis and a strong version of it and so on, and they use this to derive lower bounds on the f's. That is maybe something one can still do.
So I don't know. The kind of so from this here, and actually from this here, you get essentially conditional things that you cannot have, and to the O of something in your parameter in time. But which might not be better than what was already known, because you also had conditional lower bounds of this type. Similar kind of conditional lower bounds.
So the ICAL paper had some ETH lower bounds, right?
Yes, already, yes.
Yeah.
So it might not be better on that front, I don't know.
This is a class that is, sorry for being stupid or doing this, but this is in FPT, so it's like non-deterministic log space is included in fully time, so it's better than saying this is f of d times fully of x.
No, because you put this in the exponent, and now it's not an f of p times.
So what is the p should be d, no?
Yeah, here it should be d. I mean, it's my parameter in general. Here it should be.
Yeah.
So no, it doesn't imply FPT. Actually, it rather implies probably not FPT.
Really?
But yeah.
But the proof that ETH lower bound from the ICAL paper, it proves of W1 hardness.
Oh, okay, okay, thanks.
So it's not FPT, and this class is orthogonal to FPT.
Yeah, this proves WT hardness for every t, I think, from what I remember. So yeah, again, this rather shows probably not FPT.
Okay, this I was not aware. This is nice to hear. Many thanks.
All right, maybe I can. Thanks for that.
Okay, thanks.
I can pass the.
Any other update? So maybe there then failure. Philip, can you be first? You need slides, right?